Hi, everyone. My name is Will McCarley. In this presentation, I'll be walking you through five key ideas from design and manufacturing course that I think are super important for every engineer and that they should use in their career. This is for ME 3210. These ideas, they go beyond just coursework. They're super powerful tools that help us solve our problems creatively, smart, um, with use smart design choices and build things that are reliable, efficient, and meaningful. So to walk us through just the overview of the topics, I'll be walking through DFMA, which is Design for Manufacture, Assembly, and Disassembly and Service. Super important topic to engineering. Material selection, CNC machining, rapid prototyping, and quality assurance and SPC charts, statistical process charts. So to start us off with probably what I think is the most important topic in engineering, that's DFMA, Design for Manufacturing and Assembly. Um, the idea completely changed the way I looked at the design process. DFMA is about thinking ahead and asking yourself, how will this be built? How will it be assembled on the factory floor? Can it be taken apart easily for repairing, recycling? These small changes that we consider can lead to huge improvements in cost, speed, and performance. For example, if we eliminate a few screws by changing the geometry of a part, we can save time and reduce failure points. DFMA basically just reminds us to consider the entire product life cycle, not just the fundamental on paper does it work. And right here to the right, I found a nice DFMA chart that kind of walks us through every single thing that we need to consider when it comes to manufacturing. So, talking about the importance, the capabilities, limitations of DFMA. So, it's critical for lean and concurrent engineering, prevents late stage design revisions, which we talked about in class. Making changes up front is so much more cost effective than going back, deciding that we need to make changes after manufacturing has already occurred. DFMA helps us speak a shared language between engineers and anticipate problems before they happen. If you've ever just tried to assemble something, without properly looking at the instructions before, you know how it goes with poor design and not planning ahead. So another really, really important topic in engineering is material selection. It's one of the most underratedly important steps in the design process because every single material has a great purpose, but it's got strengths, weaknesses, and quirks. As engineers, we're not just picking materials from a catalog, we're making decisions that affect cost, durability, weight, corrosion, resistance, all these material properties that can be important to design. Looking at this really important chart to the right, it's called an Ashby chart. It's great for looking at different materials and their properties and finding where we're going to find that sweet spot on um, our design process. So the importance, capabilities, and limitations with it. It drives sustainability and product performance. I mean, if you pick a material that doesn't work, ultimately it's not going to be the best product that you can make. It's huge for recycling and availability. I mean, some metals are so easy to manufacture or produce, while others can be a lot more costly to manufacture. Um, with sustainability becoming more important in every industry, as future engineers, we need to think long term, and materials really matter in that sense. We have a ripple effect across the supply chain, so we need to be really informed about which materials we choose. So next up, we have probably one of my favorite CNC machining because I have experience with this at work. I think it's such a great machine for precision manufacturing. It's really, really interesting how they work. We have five-dimensional CNC machining at this point. On here to the right is a snippet from a textbook from Bridgeport Machines Division, but it's really, really old, simple, basic CNC machine, and they've been iterated upon, and now they're just so amazing what they can do. It's similar to a 3D printer, but instead it's using crazy powerful drill to deliver very, very precise cuts to metals. So what I use them for is carving out fridge gaskets out of aluminum, which has been very, very interesting to see how quickly it can be used, um, and how precise it can be. If it's off by even a hair, the fridge compressor won't work. So, looking at importance, capabilities, and limitations, the beauty of it is just consistency. Whether it's the first part of the thousandth, it's the same. But not everything with CNCs are perfect. The setup and tooling can be very expensive. Some of them running up to $300 an hour if you want to externally rent a CNC machine. Um, and it's not great for mass production. It does one at a time most of the time, unless you get a more expensive machine. But um, it's not for mass production. Um, Next up, we have rapid prototyping. Prototyping is a fundamental portion to the design process. It's been a game changer for engineering. It allows us to test ideas quickly and get hands-on feedback. Instead of waiting weeks for a machine part, we can have a printed prototype in hours. It's especially useful for one-off parts or early stage designs where speed really matters more than strength. And since it builds parts by layer, builds parts layer by layer, it's perfect for geometries that traditional machining really can't handle. Um, but the entire overview of this is just prototype, review, refine, and repeat that until we nail a design that we like, and then we deliver. Because, like I said before, it's a lot cheaper to make changes to your design early on. So this image shows an example of different 3D printed parts for rapid prototyping that allows engineers just to test out different ideas, see what works, see what doesn't. But as far as the capabilities go, limitations, limited strength, like I said, but that doesn't always really matter. But the importance is fast turnaround and low waste. So next up, we have quality assurance and statistical process control. So quality assurance might not be flashy, but it's an absolutely essential thing to engineering. No matter how good your design is, if the manufacturing process isn't under control, you're going to end up with defects, waste, and unhappy customers. Tools like SPC charts help us keep processes in check by monitoring variation. It's all about proactive, spotting issues before they become problems. This is another thing that we implement at work. It's great for modeling lean manufacturing when we see how our specs in comparing to past weeks. What can we do to make them better? So, like I said, here's a great example of an SPC chart where you can kind of use statistics to evaluate averages are and see what needs to be fixed. Um, as far as the limitations and capabilities go, it just turns quality into something that's measurable. We can really quantify our manufacturing process the best with these. But it only works if every employee buys into it. So really, it's fundamental to have a work culture that ensures that everyone is um, on their SPC charts and recording all the data they need. So just to wrap things up, DFMA supports efficient life cycle, conscious designs where we need to make sure that the design does what it needs to do. It can be built, assembled, disassembled, all those important topics in engineering. Not just does it work. Smart material choices really improve performance and cost. It's a fundamental portion of engineering. It's really overlooked a lot of the times, but without it, we're going to have failure or waste with cost. And then CNC, RP drive prototyping. Um, so CNC milling, going back, precision manufacturing, this thing nails consistency. Rapid prototyping helps with innovation and turnaround with our ideas. We don't have to wait a long, long time for product ideas to get back to us. And then lastly, our SPC charts ensure trust, reliability, and long-term value in the company. Make sure our manufacturing is where it needs to be and that all metrics are accounted for. Um, Thank you for listening.